This presentation is going to go over a little bit about regression, both linear regression and multiple regression. So just to review, remember that correlation statistics are useful for describing the relationship between two variables and how strong that relationship is. But we need something further if we want to explain or predict outcomes. So regression statistics is a tool we can use that helps us with explaining these relationships and predicting outcomes and characteristics of clinical outcomes.
Presentations are a powerful communication medium.
So let's use this example. If we wanted to talk about how presentations might predict whether or not a product was purchased or an intervention was adopted, we could look at X being the independent or predictor variable. That would be the presentation, and Y being the dependent or criterion variable, and that would be adoption of an intervention or the purchase of some program or something like that.
For more than 20 years, Duarte has developed presentations to launch products.
So if we're thinking about this problem of this company coming up with presentations that convince you to purchase their product or to adopt their program, let's say it's a behavior change intervention that they have developed a presentation for, you can use regression to help predict who might actually adopt this. And so you start with the regression line. And so the regression line for this example would be purchasing the product would be Y, and the presentation would be X. And the values on the prediction line are the predicted value for, we call it Y hat. So how likely are they to purchase or adopt? And the linear regression line is that statistical determination of the best fit considering all the data points in the scatter plot. So for everybody who views the presentation, who's likely to purchase, and each individual dot represents the likelihood for that one person. So our regression model is the distance from the observed value, each little dot on the scatter plot, and the regression line. And your regression equation, again, is the Y hat equals alpha plus beta X plus or minus the error. So there are some assumptions we need to meet for regression analysis. For any value of X, we can assume that a random distribution of Y scores exists. So we need random selection from a large distribution. And some of the sample are going to be above the regression line and some are going to be below the regression line. And your mean distribution of scores would be on the distribution line. And the analysis of the residuals is what we're looking at here. And we determine if the assumptions are met by plotting those residuals. So it's important to think about the outliers. Identify the outliers with your residual plots, and it performs the analysis with and without the outliers so you can see if one value changes what your values are here. And your accuracy of your prediction is influenced by several things. The correlation coefficient determines the goodness of fit of the regression line, and the coefficient of determination is your R squared. It's the total variance in the y-scores that can be explained by the x-scores and the standard error of the estimate. So we can also then look at multivariate regression models, models that include more than one predictor variable. And it considers the effects of several independent variables on one dependent variable. The process for multiple regression is to define the hypotheses to be tested, run the univariate frequencies and descriptive statistics, run the bivariate analyses, testing the relationships between the independent variable and the dependent variable, noting those that are significant, and examining the relationships between the independent variables, noting those with high correlations. Then the fourth step is to choose the variables for multivariate analysis. And you choose those independent variables based upon your bivariate analysis that you just completed. You want to select the strongest of the highly correlated variables. Then you're going to run the model, and then you're going to rerun the model for the best model. Now, how are we going to interpret this? What happens is you get an odds ratio, and that's the probability of occurrence, the odds of getting an outcome. And sometimes you will also interpret this clinically is more meaningful sometimes to have it explained as a risk ratio or the relative risk. And that's the risk of getting the outcome, giving one condition divided by the risk of another condition. So the odds ratio is at least equal to a relative risk, but often overestimates it. So logistic regression is a useful statistical tool that allows us to determine the odds of getting an outcome while controlling for a number of variables simultaneously, given the risk or protective factors for that outcome. And you will have an assignment that allows you to walk through conducting logistic regression and interpreting it.